Now we will see what happens in case of current controlled sources. First we will consider current controlled voltage source. Okay. So let me take this circuit which has a current controlled voltage source. Again, you will recognize the similarity of this circuit to the circuits I considered for the independent voltage source and the voltage controlled voltage source. In this case, the current controlled voltage source is connected between nodes 1 and 2, and its value is given by some Rm, a proportionality constant, times Ix, and Ix is defined that way. Okay. So now what do we do? As usual, when you have a voltage source, the problem is that you don't know the current through it, meaning you cannot write the expression for the current as a function of the voltage across the voltage source, right? The voltage across the voltage source is defined independently of whatever current is flowing through it. So we eliminate those currents altogether by forming a supernode. So as usual, when we form a supernode and write down the Kirchhoff's current law for the entire supernode. Okay. So as you know, any completely closed surface, whether it contains one node or many nodes, will have the algebraic sum of all the currents flowing out of it to be equal to 0. So in this case, when you write it for the supernode, any current flowing between the nodes will not appear because that current is not crossing this surface. Okay. So following the usual procedure, you form a supernode and write KCL equation. Now, because you combine two nodes into a supernode, you have lost one equation, but you have the definition of the voltage source. Okay. So V1 minus V2 is Rm times Ix. Now Ix itself is some unknown, and Ix is the current flowing through this resistor. We know that Ix is V2 minus V3 divided by R23, which of course is the same as V2 minus V3 times G23. Okay. So I will put that in that equation and write V1 minus V2 to be Rm times G23 times V2 minus V3. Okay. Now, as with the voltage controlled voltage source, the right hand side also consists of variables. So we take them to the left hand side and write V1 plus V2 times minus 1 minus G23 Rm plus V3 times G23 Rm to be equal to 0. Okay. So this is how we write the equation, and you see that it has actually come out quite similar to the case with the voltage controlled voltage source. The only difference is you had to go through an extra step to identify what is on the right hand side, because the current is unknown and the primary variables in nodal analysis are the node voltages. So you have to write that current in terms of node voltages. Okay. So when the controlling current is flowing through a resistor, whether you have a current controlled voltage source or a voltage controlled voltage source, you analyze it similarly. Okay. So finally you write the controlled voltage source in terms of these voltages V2 and V3, where Ix is flowing in the resistor between V2 and V3. Okay. So that is what we will have for a current controlled voltage source. Now there is a particular case which I have not considered, right? Let's say that we had a slightly different circuit and Ix was not over there, but Ix was through another voltage source. It could be a dependent voltage source or it could be an independent voltage source. What I am saying is we have a current controlled voltage source over there, and the voltage depends on a particular current. That current itself is not current through a resistor, but current through a voltage source, whether it's controlled or independent. Okay. Now there is a problem because you don't know what the current through the voltage source is, and earlier we formed a super node and ignored that current altogether, but here that current is controlling another voltage source. Okay, so this case is a bit more complicated and I won't deal with it here. You can of course always solve for the circuit in a more ad hoc way, and there are systematic ways of handling this also by defining auxiliary variables, which is known as modified nodal analysis. We will not be dealing with that here. So as far as the scope of this course is concerned, we will be considering only currents through resistors as controlling currents. Okay, we won't consider currents through voltage sources as controlling currents, because in that case nodal analysis cannot be used in the form that I have described. Okay.